Hello everyone. This tutorial serves to build on the tutorial that you guys actually completed prior to this one, where we discussed significant figures. Oftentimes in the laboratory, it's not just about recording numbers and putting them in a table or putting them in a graph. Sometimes the measurements that you make end up being used to calculate something else. Sometimes you have to do math with those numbers. And it's important to make sure that we are not forgetting the importance of how significant figures actually relate to the precision of a measurement, to how certain the data is. And so as a result, whenever we do math with measurements, we always have to make sure that we keep significant figures in mind. And there's a specific set of rules related to how we treat mathematical results using significant figures. So, for example, if we were to add or subtract numbers together with significant figures in mind, then basically what we would do is we would carry out the math as normal, and then what we're going to do is we're going to round the answer to the same number of decimal places as the number with the least number of decimal places that we've added together. So, for example, suppose I wanted to add these four numbers together right here. Okay, well, we would set it up much like we set up any addition of decimal values. Basically, we go and we would stack them up vertically with the decimal points lined up. And then we would add them together. Trying to make this plus sign a little bit more clear. There we go. Okay, now if we do that math, basically we get 64.9184 if we carry all the digits through without doing any rounding at all. Now, again, remember the rule, you're going to round the answer to the same number of decimal places as the number with the least number of decimal places. Well, out of the four numbers that I've added together, this number, 33.2, only has one decimal place, and it has the least number of decimal places of all the numbers that I've added together. So that means that I have to round this answer to one decimal place. So that would mean I have to stop recording the number here. If that's the case, then that means I have to use the digit immediately to its right to decide what to do with the number. Now, again, you follow the usual mathematical rules of rounding. If this digit to the right of that number that we want to round to is 5 or greater, then we round up. If it is less than 5, then basically we stay where we are. And so since it's 64.91 and 1 is less than 5, then this answer would remain 64.9. Okay, now the rules for multiplying and dividing with significant figures are actually just a little bit different. What we're going to do is we're going to do the math as normal, okay, and then we're going to round the answer to the same number of significant figures. Okay, notice the difference. Whereas when we're adding and subtracting, we're tracking decimal places. When we're multiplying and dividing, we're actually tracking the number of significant figures. So, for example, if I were going to divide 157.33 by 9.2, if I punch that into a calculator, I get 17.10108,696. Okay? Now, I would never want to see a number like this reported, whether you're taking a test for me or if you're giving me a lab report. Please do not give me a giant string of numbers because they all showed up on your calculator. You should use the rules of significant figures. And if we take a look at the numbers that we used to carry out this math, well, 157.33 has 5 significant figures. But 9.2 has 2 significant figures. So that means that my answer should be rounded to 2 significant figures. So looking at the number 1, 7, basically I want to stop reporting the number there because 1 and 7 are both non-zero digits. So that means they're each significant. So that means where the 7 is, the 1's place in the number, that should be where I stop rounding. So now I'm going to go and I'm going to use the digit immediately to its right to decide whether the 7 stays a 7 or whether it gets rounded up to an 8. Well, as it turns out, 1 is still less than 5, and so as a result, then we're going to keep that number as a 7. We're going to keep this number as a 7. So that means that this answer should be reported as 17. Okay, let's try a few more of these just to make sure we have the hang of it. So let's try these. Okay, 3.482. We're going to actually try problems 1, 3, 5, and 7 together. Okay, so basically I want to add all of these lengths in centimeters together. So 3.482 centimeters plus 8.51 plus 16.324. So remember, since we're adding, we're going to be tracking decimal places in this particular problem. So let's see, 3.482. So 482, that's 3 decimal places. 8.51, 51, that's 2 decimal places. 324, that's 3 decimal places. Well, the fewest number of decimal places is here. So that means that the answer should be rounded to 2 decimal places. So if I add 3.482, 8.51, and 16.324 together on the calculator, I get 28.316 centimeters, but I only want 2 decimal places. So it means I want to stop rounding here. So I'm going to use the 6 to decide whether the 1 stays a 1 or whether it rounds up. Well, 6 is greater than 5, so that means that the 1 should round up to a 2, and this answer should be 28.32 centimeters. Okay, let's try number 3. 80.4, so again, now we're subtracting 16.532 centimeters from the 80.4 centimeters. So once again, this is a subtraction problem, and once again, we're going to be tracking decimal places and not significant figures. Well, 80.4, that's 1 decimal place, okay? And then the other number, 16.532, that's 3 decimal places. I want to report the answer to the lowest of the 2 number of decimal places in the numbers that I'm working with mathematically. So that's 1 decimal place. So that means that the answer should be reported to 1 decimal place. So if I take 80.4 and subtract 16.532 from it on the calculator, then I'm going to get 63.868 centimeters, but I want to report it to 1 decimal place. So that means I want to stop writing the number there, and that means I'm going to use this 6 right here to decide whether the 8 stays an 8 or whether it rounds up. But 6 is greater than 5, so that means that 8 should round up. So this should be 63.9 centimeters. All right, let's look at number 5. Here I'm multiplying, right? So since I'm multiplying, now I'm going to track the number of significant figures. 48.2, okay, well that's 3 non-zero digits. So that's 3 significant figures. 1.6 centimeters. Well, 1 and 6 are both non-zero digits, so that's 2 significant figures. And then 2.12. Well, 2, 1, and 2 are all non-zero digits, so that's 3 significant figures. And I want to report the answer to the least number of significant figures of all of the numbers that I'm working with mathematically. So of these 3 numbers, 2 significant figures is the least. And so that means that I want to report the answer to 2 significant figures. So if I do this multiplication on the calculator, I end up with 163.4944 centimeters. But I want to report this to 2 significant figures. So that means I want to stop writing the number there. Now, we have to be careful because I don't want to just say 16. All right, I can't change the value of the number. It has to be about 160 something, right? And so what I'm going to do is I'm going to look at this number right here. And that's going to help me decide whether the 6 is going to stay a 6 or if it's going to round up to a 7. Well, 3 is less than 5. And so since 3 is less than 5, then that means that that 6 stays a 6. And that means the answer should be reported as 160 centimeters. Notice again, I'm not going to put a decimal point after the 0, because if I put a decimal point after the 0, then remember this trailing 0 would become significant, and that would be 3 significant figures. I want to leave it as 2 significant figures. And if you recall to the last tutorial, basically if I have no decimal point in the number, then this trailing 0 stays not significant. And so this would actually be acceptable if I only wanted to report this answer to 2 significant figures. Now, let's take a look at the last one. I have 64.34 centimeters centimeters squared, okay, divided by 8.149 centimeters. So again, division has the same set of rules as multiplication when it comes to significant figures. So again, I want to track significant figures in this problem instead of decimal places. 64.34, that's four non-zero digits, so that means they're all significant, so this is 4 significant figures. 8.149, well, that's also 4 non-zero digits, right? 8, 1, 4, and 9, so that's also 4 significant figures. So that means that my answer is going to be reported to 4 significant figures. So if I do this math on the calculator, 64.34 divided by 8.149, that's going to give me, and it's a long number if I actually show everything on the calculator, but it's 7.895447294 centimeters. Okay? But again, I only want 4 significant figures. So that's 1, 2, 3, 4. I want to stop writing the number here. So that means that I want to use this number to decide whether or not that 5 on the other side of the line that I just drew will stay a 5 or if it rounds up to a 6. Well, 4 is less than 5. And so as a result, then that 5 stays a 5, and this would be 7.895 centimeters. Okay? So really when it comes down to using the rules of significant figures for mathematical operations like this, it just takes a little practice, and the more you practice, then the easier it gets. You'll remember things a whole lot better, and it won't seem like it takes so much thought to actually go and use the rules of significant figures when you're trying to do these calculations. If you have any questions, by all means, email or see me in class tomorrow. Have a good night, and I'll see you guys in class.